There are n children given and they are sitting in a circle. Every second child is removed from this circle until there are no children left. Our task is to find in which order the children will be removed. So every second child. So if this is our starting point, then every second child will be removed. So this would be the second child, this would be the second child. That means alternate children are removed and we need to print in which order the children will be removed. Let's take an example. Here the number of children are 10 and then we need to, now this would be our starting point and now we need to remove the second child. So we'll remove this second, now this 4, then second child 6, sorry, then 8 and then 10. So we are simultaneously displaying the order in which they are removed. And now since here 10 was removed, now our second child would be, we will not remove 1, we will remove 3, right? Because that 3 is our second child. So we'll remove 3, then 7, then 1. Now now in the next iteration we are not going to remove 5 because 1 we removed, so we'll remove 9 and then we are left with 5, so we will remove that. That means I can say that we need to know the starting point on every iteration. So for instance 1 2 3 4 5 6 7 8 9 10 was there, so this was our starting point. So we removed 2 4 6 8 10, 2 4 6 8 10. Now this problem is being reduced to a smaller problem, which is 1 3 5 7 9. So now in this problem our starting point is this. So we removed 3 and 7 and then 1. Now for this problem our starting point is 5, that's why we are removing 9. So it is clear that we need to know the starting point and every second child is being removed. Every second child is being removed. That means no matter what the configuration is, you are gonna remove the second child once we know the starting point. Let's see one more example. Okay, let's see for n equal to 6 children. They are sitting in the circle and I have written this in linear fashion in the array or list form. Let's not try to focus on the data structure right now. Let's try to understand the problem. So n is 6 and this is written in a linear fashion. Let's write the indexes also 0 1 2 3 4 and 5. Now every second child is being removed. So if we are starting from here, this is our starting point, then related to this second child will be removed 2 4 and 6. So we'll display 2 4 6 and here also 2 4 6. And if you see keenly, then the children which is present at odd indexes are being removed. Children present at odd index 1 3 and 5, they are being removed. So now we are left with 1 3 and 5. That's 0 1 2 and 1 3 and 5. What shall be our starting point in this case? As we have seen in the previous slide, we need to work on the starting point and we remove the second child related to the starting point. So if you see, we removed 6. Now the second child would be, this wouldn't be the second child, 3 would be the second child. So in this case also 1 is our starting point. So related to this, we will remove 3, and also it is present at odd index 1. Now we have to remove 1, and to do so we are removing the children present at odd indexes. So we remove 3. Now we shall remove the children present at odd index, but we don't have any odd index. It is exceeding the length. So this pass is done, that means, and then we will have 1 and 5 like this, and this will be 0 and 1. Now 1 and 5 are there, and in this case what shall be our starting point? So if you see that we removed 3, now we will remove not 5 but 1. So we are removing this, and 5 has to be then starting point, not 1, right? Because you removed 3, we are not gonna touch 5, we will touch 1. So in this case this would be our starting point. Now then if this is our starting point, we shall remove 1, but we are removing the children present at odd indexes when they are written in the list format. Then if you see that 1 is corresponding to an even index, it is not at odd index. If it was at odd index, then we could have clearly removed it, saying 5 as a starting point. So how we can make the 5 as a starting point and 1 to push it in, push at odd index? It is at 0, it is at 1 index. What if I switch this place? I bring the 5 at the beginning, meaning I bring 5 over here and 1 over here. That means 5 at the beginning, then this would be 0 and this would be 1. Now this is our starting point. We remove the children present at odd index, so 1 shall be removed and we will be left with 5. We will be left with 5. Since this is the only child left, we will simply paste this over here, and this is our answer. Okay, so from this we conclude that uh, we need to figure out how we can more systematically find the starting point, and we are removing the children present at odd indexes. Let's take one more example. When n is 7 and we have here our list 0, 1, 2, 3, 4, 5, 6. These are just children numbers written in the linear fashion. So the beginning, this is our starting point, and we know we remove the children present at odd indexes. So 2, then 4, then 6. So 2, 4, 6, and then 2, 4, 6. We are left with 1, 3, 5, and 7. 1, 3, 5, 7. Okay, so 0, 1, 2, 3. Now what shall be our starting point? So we removed 6. Now in the next part we will remove 1, right? We are gonna remove this 1. So in that case, that means 7 has to be the starting point and 1 has to correspond to the odd indexes. To remove 1, it has to correspond to odd indexes, and right now it is at even index 0. So how we can deal with this? Simple. We bring 7 at the front. If we bring the 7 at the front, meaning if we do like this 7, then 1, 3, 5 remain as it is, and this corresponds to 0, 1, 2, 3. So if we bring 7 at the beginning, then 1 will automatically be we thrown at the odd indexes and though the other child also. So that's 7 is our starting point, in other words. So 7 is our starting point. So related to that, we need to remove the second child. So we removed 1, then we will not remove 3, we will remove 5. So if you see in this, we remove 7 is our starting point, related to it the second child. That means the children present at odd indexes. We are deliberately making 7 to be at even. That's so because that becomes the even, and related to that, though the other second childrens are becoming odd indexes. So we remove 1 odd index, then children present at odd index 3, 5. So we display 1 and 5, and now we are left with 7 and 3. So let's write over here 7 and 3, 0, 1. So we removed 1, we removed 5. Now the second child would be 3, right? We are not gonna touch 7. So that means what shall be our starting point? We removed 5, now we're gonna remove 3. Same to that, 7 is our starting point, right? Because that would correspond to the alternate child. So 7 is our starting point again, and we remove 3 corresponding to the odd index 3, and we are left with 7, and that is just single child. We simply paste, and this is our answer. Okay, so from this we are sure that we are removing the children present at odd indexes, and we just need to figure out the starting point, and we deliberately make it to point at even index. So in that case, the other would definitely become the odd, and also we need to figure out when we are pasting this 7, this last children at first, because that is also important when we are pasting the last children at first, because somewhere we are pasting and somewhere we are not. Okay, let's take another example, and this example would surely help us to figure out. So we have the list, we have the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, and we know we remove the children present at odd indexes 2, 4, 6, 8. So children present at odd indexes 2, 4, then 6, then 8. Now we are left with 1, 3, 5, 7, 9. 0, 1, 2, 3, 4. 1, 3, 5, 7, 9. Now let's figure out what shall be our starting point. We removed 8. Now we will remove 1. Correct? And to remove 1, 9 has to be our starting point. This has to be our starting point. But and this 1 has to then correspond to the odd indexes. Right now it is at the even index. Okay, so that means we need to bring the 9 at the front. So here we are bringing 9 at front, and if you see, then we are left with 5 children. Earlier we were having 9 children. Okay, so that means this 9 is odd, right? Earlier these were 9 children. So, and the array length is also 9. So if 9, if the length is odd, then we are bringing last to first. Okay, so last to first, so that means this would be 9 1 3 5 7. Since this is our starting point, this has to be present at even index. Then we remove, if this is the starting point, we remove 1 5, we remove 1 5, 1 and 5. Now there are no more odd indexes left. That means we have completed this pass, and now we are left with 9 3 and 7. Okay, now what shall be our starting point? This is important. We need to figure out what shall be our starting point. So we removed 5. Now we need to remove 9 and 9, so that means 7 shall be our the starting point, and right now 7 is sitting at the back. That means we need to bring 7 at the front. Why we are bringing 7? So let's see. Earlier we were having in this 2 2 4 5, so 5 is odd, so that means this condition we bring 7 at the beginning. So let's bring 7 at the beginning. So let's write here 7 at the beginning, and then we have 7 and then 9 and then 3 0 1 2. Seeing to this, we remove 9, because that is corresponding to the odd indexes. So we have, let me use another one. So we have now we are left with no more odd indexes left, so we are left with 7 and 3. And what shall be the starting point? So we remove 9, we are not gonna touch 3, but we will touch 7. We have removed 9, we are not gonna touch 3 because that does not correspond to the odd this second child or the odd index. So 3, then that means it has to be come at the beginning, right? Because 3 and 7, and you can see 3 is odd, right? 7 9 3 3, these are odd. That means 3 has to come at the beginning. So if we bring 3 at the beginning and 7 at the back, corresponding to this, we remove 7 and then 3 is left, so we do 3. So let's take one more example and let's try to summarize everything when we are doing it, is when we are bringing the last at the beginning and when we are not bringing the last at the beginning. So let's take for n equal to 10, and here things will be clear. Okay, so let's start. This is our list. We have 0 1 2 3 4 5 6 7 8 9. We simply write the children present at odd indexes. Those are our first answer. So 2 4 6 8 and 10. 2 4 6 8 10. Now we are left with 1 3 5 7 and 9. So we have 1 3 5 7 9. 0 1 2 3 4. Okay, what shall be our starting point? Let's see this. We remove 10. Now we are not going to touch 1, we will touch 3. So clearly 1 is our starting point, and we can verify it from our list. Earlier, before deleting, we had the configuration 10, total length as 10, and 10 is even, so we are not touching. In the previous slide, we have said when the things are odd, then only we go for bringing the last in the beginning. So 1 is our starting point, we remove 3, we remove 7, we remove 3, we remove 7, and we display it 3 7. Now no more odd indexes left. We simply write this 1 5 and 9. Okay, so 1 5 9. Okay, before doing this, what's the configuration earlier before removing? So we had 2, 2, 4, 5. We had 5 children, and 5 is a odd number. That means we see earlier configuration, 5 is an odd number. So that means we have to bring the last in the beginning. Is it going with through here? Let's see. So we remove 3, we remove 7. Now we are going to remove 1. We are going to remove 1. So 1 has to correspond to odd indexes, but right now it is present at even index. That means 9 shall be the starting point. So we bring 9 at the beginning. So 9 1 5 0 1 2. So we remove 1, left with 9 and 5. 9 and 5, we remove 1. Now again, see the earlier configuration. 3 3 is an odd number. 3 is odd number. That means we need to bring the last to the front. Why? Let's see here also. We removed 1. Now we are gonna remove 9. 9 has to correspond to odd index, but it is right now even, and then 5 has to be the starting point. Right? We remove 1, then we shall remove 9. 5 is our starting point, and we bring 5 over here because earlier configuration 195 is an odd number. Right? This is odd number, so that means there would not be a complete cutoff. So 5 and 9, we brought 5 at the beginning, and we remove 9 now. 9, and since 5 is left, we simply write this. Great. So when the configuration was odd, we were bringing the last to front whenever the configuration was odd. Here also the configuration was odd, so we brought last to front. So let's write the code, and also before diving to the code, let's look for the data structure. What data structure shall we use here? We were writing list here, but do you think list is list or array? In array we are using vector. So do you think this is a right way of using this data structure? Because when the configuration are odd, then we bring the last to front, but in vector we have only pushing from the back. We can't push things from front, right? In vector we push back things, not we push from front. So what data structure shall we use in which we are comfortable in pushing from front also as well as from back also? So dec or dq is the data structure which we can use here. What does this dec allows is, dec is just like an array, but you can push and pop from back even, and also you can push things from front, and also you can remove. So it can be elongated both ways, from front or back. It can be also deleted from front and back. So since we are bringing the last to front, then using deck would be more clever. So we will use stack, and if we have not used stack anytime before, we will see with this an example only how deck simple it is to use. Alright, so let's go over our VS Code. Okay, so Josephus problem. N children, the only input it has integer n, and then we need to have the removal order. Constraint looks good. So okay, let's have our input t n children. Then we must use deck, and we are using deck because it allows pushing the numbers from front. So it's simple, as we used to do in vectors. We have the deck, we have the object type and the name of the deck. Let's go with numbers and have the size as n. Now okay, so when n is 7, let's take n is 7, then we must have the numbers from 1 to 7. 1 2 3 4 5 6 7. We need to fill. So for filling we can use a for loop, but let's go with inbuilt function iota. So iota fills the number with the specified starting position. So numbers.n, we want complete and the starting number. So let's see here. Here is our deck, and let's say n is 7. So n is 7. That means we will have 0, 1, 2, 3, 4, 5, and 6. So we have this 7 length deck, and then I'm saying iota numbers dot begin to numbers dot end from 1. So this is starting number you want. So this is starting 1. So we will have 1, 2, 3, 4, 5, 6, and 7. We have this 7 children configuration like this. Then we need to remove the children present at the odd indexes. That means we need to catch hold of this odd indexes and we need to display, right? We need to catch hold of this odd indexes. So let's do that. So for doing that, let's use simple int I is 0. I should be less than n and I express. Now we'll see. Let's make this numbers dot size. That would be okay. So we go up to the numbers dot size and we check here. What we need to check, if the index is odd, right? So if I, so I'm using bitwise. It's just a fancy way of writing I mod 2 not equal to 0. Bitwise is much faster also, but doesn't matter which you choose for checking the index to be odd, and we will simply just display this. If the index is odd, we display 1 2. Okay, next 3 is odd, 4 display, and then 6 display. So we are catching hold of the odd indexes and we are displaying. And then we also need to have the left numbers, right? So these are left numbers, 1357, 1357. We don't require this 2, 4, 6 now. So what we can think of is, if the indexes is odd, you display, and if it is not, then you simply throw them in a different deck. So let's create a different deck of left number. So this left number would have the numbers present at the even indexes. So we'll push back these numbers. So if it is indexes are odd, display them, and if it is even, then push back those numbers in this deck. Okay. Now also we need to take care of this this thing. When the length is numbers dot size is odd, we need to bring the number in last number front. So let's write here logic for bringing the last to front. Okay, so we'll say if, what we need to say, if this numbers dot size is odd, then we need to bring. So we can simply use the bitwise and to check the odd condition. If this is the case, then bring the last number first. So this last number, how we can catch this last number? This is simple. Last number index we need to catch hold of. Let me write, and then it will be clear. So I will say left numbers left numbers dot size -1. So this would take care of this. So basically this line is the left numbers dot size. So what is the size? 1, 2, 3, 4. So 4, but the indexed would be 0, 1, 2, 3, and the size is 4. So 4 minus 1 would be 3. 4 minus 1 would be, give this. Then we need to remove the last number. So we'll say pop back. So that last number would be removed, and we need to paste this in the front. So left numbers dot push front. This is the special function present in deck to push the numbers from front. So we'll push this, and also this numbers, we don't require those numbers, right? Because our numbers are now the left numbers. So we'll clear this out, and we'll equal left numbers. So we have cleared out this main number, and because our left numbers are now the numbers, right? We can see here this number has been cleared off, this number has been cleared off, and this left numbers are our new numbers. So this is there. And if numbers dot size, if the size is not odd, if it is simple, if it is not odd, then we can simply copy this, right? Because we don't have to make the adjustment for bringing the last to front. And this we need to keep on doing until we are left with numbers dot size numbers dot size is greater than 1. We need to keep on doing this, because as soon as we hit the last number, we simply display the this. And also we made a copy here, and also we need to empty the left numbers, right, to start storing the new numbers in this. Left number is this. Now when you are going to remove 3 and 7, then this has to be cleared off. So we'll clear this left numbers dot clear. Okay, so let's take an example and study. So here let's take n is 7. So n is 7, that means we have this, and these are 0 1 2 3 4 5 6. We have this. Iota will fill this from 1 2 3 4 5 6 7. Then we'll catch hold of these odd indexes and we'll display. So we'll display 2 4 and 6. At the same time we will keep on filling the even indexes, which are 1 3 5 and 7. 0 1 2 3. So these are left numbers. These are this. Then we'll say numbers dot size. So numbers dot size is 7. 7 is odd, so we need to go over here. Left number dot size dot 1. So we'll catch hold of this and we'll write first is equal to 7 here. This is simple. Then we will pop back. So this is going to be pop back. Then we will push front this first. So 7 is going to be push front from front. So 7 would go here. Then other numbers would remain as it is, 1 3 and 5. These are indexes 0 1 2 3. And we will clear off this number because this numbers is we don't require, and this left numbers would become our new numbers. So we have this numbers and we will clear off this left number also, and we'll go again. Still the number dot size is not 1, it is 4. So again we will display the odd indexes 1 and 5. So 1 and 5 would be the answer, and we will have the left numbers. So this will go off and we'll have 7 and 3. 7 and 3. Then we will check number dot size is not odd, right? It is 4. 1 2 3 4. 4 is even. So we will simply go over here and left number will become our this new number. Left number would clear off. Again we will go and we will display the odd indexes, which is 3. So 3 will be displayed, and we will have left numbers as 7. Then we'll see if this is odd number dot size. No, it is even. 2 is even. So we will not go over there. We will go to the else block and numbers will become out this number. And then we'll check if number dot size is greater than 1. No, it is equal to 1. So we'll come out of the loop and we'll display numbers 0. So number 0 would be 7. 7 would be displayed. Okay. So let's try to submit this now. So submit. Okay, it has been accepted, and this, you can ignore this warning. This is saying we need to do the typecasting int here to get rid of this warning, but it's okay, you can do that. And that's it. And one special thing, we are using deck. That is so because deck has the property of pushing back and pop from back, and pushing from front and popping from back. So this is deck. And if you see the other, let's say vector, so you can only do stuffs from push back and can delete from back. So that's why we are using deck over here, because we can insert from front. Okay.